Okay, so my first hour asked me to make a video on lesson 3.4 in 5th grade GoMath, which is rounding decimals. And rounding decimals is a very, very old skill. I'm talking like you really started doing rounding when you were 6, right? So if you look at the top of your notes, you see this old rhyme. Would you like to read the old rhyme for us? How do we remember what the rules are? Because remember, estimation is like rounding, but we just make the numbers work for us. We change them till they work for us. In rounding, we've got a really specific set of rules. You want to read our set of rules for us? Got to be loud for camera, though.
3.4 rounding decimals. 5 or more, raise the score. 4 or less, let it rest.
So there's a couple of things that have happened in these notes. First thing is, I put in a little hashtag. When we're doing rounding, decimals don't matter today. Because somebody did point out, they certainly do matter. But in today's lesson, we leave the decimal alone. Hashtag leave decimals alone. When we're rounding, we are concerned with digits. We are concerned with place values, decimals. Let them be. Leave them where they're at. Don't change them. When we're rounding, we are worried about digits. All the decimal is doing is happily sitting there separating your wholes from your parts. It's not doing anything else. So if we're worried about digits and place values, decimal, stick it there. Let it do its job. Leave it alone. You have a table in your notes. Look. This, which is, if you'll notice, incorrectly labeled. So, what's incorrect about those labels? Somebody raise your hand. Don't yell it at me. Yes, ma'am.
The letter, the words aren't in the right spots.
The words are not in the right spots because they're the wrong words. I have tens here. This is tenths.
And then hundreds.
Tenths, not tens. Tenths. So make sure you change these in your notes. Then we've got, I heard somebody say hundredths.
Okay.
And then thousandths. So when we're working with the number and we've got a decimal place here, I'm going to double mine. If you want to double yours, that would actually probably be useful for you. We're going to stick our decimal places in there. We've got our holes. We've got our parts. We're going to leave it be from there. But a trick when we're saying these numbers out loud. When we're saying these numbers out loud, it's the word and that tells us where the decimal point is. Ones and parts. So when we say a number out loud, we replace the decimal point with the word and, just so you can kind of keep track, so we can make sure we're saying these numbers correctly. When we are rounding, we have to decide what place value is important, right? But first, let's talk about what rounding actually is. This number, and I'm going to represent it visually with these cool little magnety kind of base 10 blocks. Somewhat magnety. They've been in this bag way too long. There's a 1, right? 2, 3. Got my whole numbers covered, right?
Mm-hmm.
2 tenths.
Mm-hmm.
7 hundredths. How do we represent thousands? We don't represent thousands with base 10 blocks. They're way too small. We would have to slice this into 10 equal pieces, and then every time somebody sneezed, they would just blow all over the place. But if we're going to round, we're never rounding to the smallest place value, are we? Because we need another place value that is smaller so we can know what we're going to round this to. So we're not worried about representing our thousandths, but let's go ahead and round to our hundredths place. In order to round to this place, here's what we're doing. We need to see how close this next place value is. When we're rounding, we're either pushing this number up to an 8, or we're just leaving it alone, right? What this actually means, because when you're a little kid, they teach you this rhyme, they teach you how to do it, but you don't think a whole lot about what it means. And this is what makes rounding actually kind of a harder skill. What this means is, how many of these do we need to change our next place value higher? Our math is called base 10. So we need 9 of these because the 10th one is going to change this into an 8, right? This is basically a 71. 72, 73, 74, 75, 76, 77, 78, 79. Then we would bump up and change this to an 80 and would not have any more thousands. If we're more than halfway to our next number up, then we round up. 5 or more, raise the score. So if this was an 8, we would be almost all the way to an 8 here, right? So if we're rounding and we're only thinking about this place value, we would just push that up because we're close enough already. Since we're talking about a 1, are we close enough to push this 7 up to the 8, or are we only a little bit of the way there? No, if you had $1, you couldn't round it up to $10, could you? No, so being 1 out of 10, we're not anywhere near close enough to push that place value up. So we go with 4 or less, let it rest. Because if it's 1, 2, 3, or 4, that's less than halfway to the next number, right? If we're less than halfway there, we just turn around and go back and leave it alone. Now, one of the most important things to think about when we're rounding, the place values that are bigger that we're not working with, we don't touch them. We leave them alone. We bring them down, we add them in. So, since we rounded this, we're looking at this. 3 stays the same. Decimal should always be there. 2 stays the same. Did we raise the score or did we let it rest?
Let it rest.
We left it totally alone. So when we rounded 3 and 271 thousandths to our nearest hundredths place, we didn't have enough to push up to the next place or to the next digit. So we ended up with 3 and 27 hundredths. We decided these were too small. We didn't really care about them, or was inconvenient, or whatever. Because remember, rounding, we're just trying to make it easier. There weren't enough to make it move up, so we just left it alone. When I was a kid, I always liked to fill in my zeros. Because when I'm comparing these numbers, I always wanted to know, see in my head that I'm zeroing this out. Is it technically necessary? No. Does it help? Yeah, especially if you're a visual person like me. Visually showing, I keep this number because I wasn't messing with it. I keep this number because I wasn't messing with it. I left this one alone, but I already used these, so I dropped that. Then my final number that I'm going to get. Is there a difference between these two numbers? No. This is 3 and 270 thousandths. I just have an empty place value there. It doesn't change what it's actually worth. This is 3 and 27 hundredths. This empty place value here doesn't change anything. So that was letting it rest. Let's go eraser. Let's bump up a notch. And I want to round instead to my 10th place. Yes. So we're going to look at our 100th place, right? She says raise the score. Why? We are 8/10ths of the way to changing this to a 3 anyway. If we decided this was the smallest place value we wanted to deal with, yeah, we're totally going to raise the score. But question, this is a big number. What do we do with it? Keep it? Use it? Ignore it? What?
Use it?
What would we use it for?
1,000.
True. But think about how little a thousandth actually is. If you could cut this into 10 pieces and take 9 of them, you still don't even have one of these, right? So if we are going to look at this place value and round it using this place value, is there enough stuff here to change our mind or influence us in any way?
Yeah.
Or is it just a whole bunch of really little stuff that we're going to go ahead and drop anyway? That's not what I was asking. Is these 9 thousandths? That is, this cut into 10 pieces and keep 9 of them. When we're working with these bigger parts, are these 9 thousandths big enough to have any real influence on us? Do we really care about them? If we're using this place value to round this place value, is this enough to make a difference, or can we just kind of ignore it and drop it when we're done?
Ignore it.
Yeah, we can totally ignore this one. We're using hundredths to round our tenths place. This is so small, it's not really going to change our judgment any. Now, when we look at that digit, like she said, this digit looks like a bunch of stuff. But you got to remember, it's 3 place values below the decimal. It's like microscopic. It's so small we don't even use base 10 blocks to represent it because we don't want to sneeze and mess up our math, right? So we don't really care about this one. We're looking here. We've already seen it instantaneously. Yeah, we're going to raise the score on this too because we're almost all the way up to a 3 here anyway, right? We did 29, 30. We're almost all the way there anyway. So if we're going to zero out this place value and round it to this place value, we're closer to this than we are keeping it at a 2, right? Bring down our 3. Kept it, didn't mess with it. Kept it, didn't mess with it. Brought it up because we were almost there anyway. So we went from 3 and 289 thousandths. We rounded it to our tenths place and ended up with 3 and 3 30 hundredths, which if we get rid of our extra placeholder 0, is 3 and 3 tenths. Sorry, forgot to zero out both my place values. A couple of the most important things to remember. Everybody remembers these because they're cute and they rhyme and you've been doing them since literally like first grade, right? The harder things to remember are those bigger place values that you didn't mess with. You have to keep those numbers there. You can't just zero out every other number in the problem. You have to drop your place values that you are past using. This stuff is small enough. We've decided if we're rounding, if we're trying to make this number easier, we don't need it. Now, a question. What if we were rounding to our ones place? Would we have to keep this decimal here?
Yes.
No, yes, no is the look on everybody's face. Why? Be loud because you're far from the camera.
No, because if you round into ones place, like if you're rounding a 1 with a 10, then there obviously be nothing here, so it wouldn't matter.
Correct. And I don't know if that picked up on camera, but it was awesome. Yeah, if we're going to round to the ones place, we're using the tenths place, but we're definitely going to drop it. So do we have to keep this decimal here if we're rounding to the nearest whole number? No, we don't. We only need this decimal here to show, hey, holes, parts. We only need this decimal here to build that wall between the holes and the parts. There are always decimals in a number. They just might be separating at a 0. Like if it was my 39th birthday, I would be 39.0 years old, right? Or 39 and 0 tenths. Do I have to have 0 tenths? No. Am I wrong if I do? No. In 6th grade, there reaches a point where you are required, you have to drop these extra zeros because that's what's expected, because they'll get in the way of doing bigger math. In 5th grade, I'm going to tell you this. It's like training wheels. If you need these place values as zeros like I did when I was a kid to kind of keep things lined up, use them. But once you get more used to using them, try to drop them. Try to see what you can do without them. Give me fist of 5. 5, yeah, this seems pretty easy and I'm pretty cool with it. Fist is, oh my gosh, no, please help me. I'm seeing 10s, that's pretty good. I would say if you're at a 3 or higher, you're probably okay. If not, I want you to go ahead and get started on our assignment and try a couple, and then we'll come back to a small group. Extreme close-up.